It's been a while, but I'm back with another small tutorial, and this time I went really heavy on the experimental side of things. I hope you guys will enjoy it. So let me get straight into the heart of the video and show you what there is to know about this little project. The first thing you'll probably notice is that we've got a bunch of astronauts and they all seem to be very surprised about what's happening. What we know for sure is that something is either hitting the ground or blowing it up from below, but without getting too lost in the story beyond the setting, one of the interesting technical aspects about the scene is the rock that is hitting the ground, which is using a combination of a new material available in React tree fiber that's called MeshTransmissionMaterial, which opens up so many new possibilities. In fact, these beams of light are also using the same material, but we're also going one step further this time by creating our own customized shaders. That's right, we've never seen how to create custom shaders up until now, and that's because shader coding is usually difficult, but a new interesting tool spawned recently called Nodetoy, which makes it really easy to get introduced into the world of shaders, and we're going to use it to create the rim light effect of the Meteor and also the ground effect that's generating these quick lighting strikes on the ground. And I've already talked a lot, so let's stop the intro here and jump straight into VS Code to get started with the project. The code base will be available in a Github repo that I'll share in the description of the video, and each episode would also have its own branch so that it's easier for you to just inspect the code instead of having to fully tap it out if you don't want to. Alright, this time we'll use Vite to kickstart a project. Just type the create command that you see on screen. I'll also do it right now on video, and we can use a dot as the project name. This will use the currently active VS Code folder, and then we'll select React and JavaScript as the preset. Once the step is complete, we can npm install and we'll be able to use Vite as the build tool of the project. Alright, next step will be to install all the packages that we'll use throughout the project. I'll run one by one each of these commands, and if you don't want to type them out, I'll leave these lines in the description of the video. And now that I've got all the dependencies installed, I went ahead and removed all the files from the source and public folder and created 3 new files. Index.css will make sure that the 3D canvas covers the entire screen. Then main.js will simply initialize the React application, which we're wrapping inside the canvas component from React tree fiber. And the application file will be an empty component that we're going to populate in a moment. And we'll do this now so that you don't have to think about it later. So basically I want you to download the content of these 2 folders and put them inside the public folder in the app. I'll leave a link in the description to the repo of the project as soon as it goes live, and you'll be able to find these 2 folders under the public and assets folders of the repo. And these folders contain basically the GLB, which are the 3D models of the scene, along with the textures that we'll use to create the scene with React tree fiber. There we go, I just downloaded these 2 folders and I placed them inside the public and assets folder path inside VS Code, and now we're ready to populate the app component. We'll start by adding the environment map, which is basically the 3D background of the scene, and using an environment map is also one of the simplest ways to create the lighting and reflections of any 3D model inside React tree fiber. Similarly to what we've done in the last project, I'll use 2 different environment maps. One will be used exclusively to calculate the reflections of the scene, and the other one is only going to be used as a simple background. I need to split the 2 because the background environment map is blurred out, while the one that we're going to use to calculate reflections is not. To be a bit more specific, 99% of the lighting of this project has already been baked in Blender, so we don't have to calculate any reflection because they're already included in the textures of the model. But the visors of the astronaut do need to display dynamic reflections, and that's the reason why we need a specific environment map to calculate these reflections. And this property is new for us. We've seen in other projects that environment maps can be imagined as gigantic spheres that cover the entire screen, but that will leave the impression that objects are floating in space when we add them to the scene. But by using the new ground property, we can change the environment map projection and give the illusion that objects are sitting at the ground level of the environment map. And I'll show you in a moment what that looks like. Lastly, we're creating our default camera and the orbit controls. So this component is the component that will let us move and pan and rotate the scene around. As a quick reminder, the target property is the point in space in the 3D world where you would be orbiting on. Great, now we just have to type npm run dev, then I'll hit enter, and as soon as the local server is ready, we'll open it up and see the result. You'll probably just see a dark screen, but if you start to move around, you'll notice that we are indeed using an environment map. And the environment map that we're using is also ground projected. So as soon as we start placing more and more objects in the scene, it will look like they are sitting on the ground of the environment map, when in reality this is just a perception trick because we're ground projecting the environment map. And to make it easier to visualize this trick that I'm referring to, this is the non-blurred environment map, and if I move it around, you'll see that it looks like there's a ground in place when in reality there's not. This is just a perception trick because without the ground property, the environment map would just look like this. A gigantic sphere that is covering the entire screen, and it will also look like we are above the ground level, floating in space. Alright, time to move on. I've created a suspense block inside our app, and I've also created a scene component where we're using the gltf hook from React Tree Fiber to download the 3D model that contains most of the objects of the original scene, and we'll start with the ground geometry, so we also need to download its texture with this hook, where we just have to specify the path, and then we'll be good to go. Now that we have both the model and the texture, we can assign it to a mesh. So in this case, we'll assign the ground geometry. The nodes model I've created in Blender such that it exports a bunch of geometries, so the ground, the astronauts, etc. So in this case, we're just referencing the ground geometry and we're assigning it a mesh basic material because the lighting of this object has already been baked with the ground texture, so we don't need to use the standard material. We can just splat a texture on it and it will look like it's being lit on by the rest of the objects of the scene. And there's one last step before you can see our model in action. We need to increase a little bit the tone mapping exposure of the scene to make it brighter, and we can do that by accessing the renderer settings with the use tree hook. Great, now we have our first piece of the puzzle, but it looks kind of weird because it's just a single object, and if we're missing all the other elements, the baked lighting effect is not going to make much more sense. So we're going to add all the other objects and then see what this scene looks like with all the elements in it. Back to the scene component, I've added a bunch of new elements, and don't be scared, even if there's lots of new lines in here. I've just basically repeated the same exact process that I did for the ground component for the other meshes as well, like the astronauts or the exploded fragments, etc. In short, for each of these textures, there's a geometry that is associated with it, and I'm also creating a mesh that is referencing that geometry and that texture. And I'm repeating the same process for all of the textures that are referenced in here, with one exception, the visors of the astronauts. As I mentioned previously, the visors need dynamic reflections, so I can't just splat a texture on it and hope that the lighting will look okay. In this case, I need to use a standard material, and it will reference the environment map that we're using in the app component to create the proper reflection of this mesh. And this is necessary because the visor will act like a mirror, so the surface will be super smooth and the reflections will be very sharp. And to achieve that look, I'm using roughness to 0 and metalness to 1 on the standard material properties, and I'm also setting a custom color that will reflect the original color that we've seen in the intro of the video. And there's definitely a much better way of organizing all of this. I could have created an object that is referencing a property that is also then specifying an asset, and then we could use a simple for loop or an array or something to just generate all these lines without having to copy paste a million things. But it's also 5 AM, I should probably go to sleep, so we'll leave this mess as it is, like a true chat developer. Hey, but look at our scene now. It almost feels like we're already done. Most of the static meshes are there and the lighting now makes total sense. This is the beauty of baking lights in Blender. If you're okay with having a static scene where you can only move the camera, it will still look amazing. But there are limitations to it. In fact, we had to create a separate component for the reflections in the visors of the astronauts. And if you look closely, they're only going to reflect what is visible inside the environment map, so these are not totally accurate. But if we zoom out and you look at it from afar, hopefully you're not able to spot this little trick and the scene ends up making sense visually. Alright, this feels like a great introduction to this little project, so I'll stop it right there, and in the next video we'll start to take a look at how Nodetoy works and how you can use it to create interesting shaders. I hope you guys are enjoying the process so far, and if you have suggestions about the format of these videos, please share your feedback. Know that it's always appreciated, and I hope you have a great day, and I'll see you on the next one.